load analysis and live load analysis. Then we'll check some results for the bridge. We'll do some load combinations as per ask the code, and then we'll do a design of the composite bridge using ask the code, and probably we'll have a question and answer session at the end of the webinar. So to begin with, the bridge information. So currently we are having a 3-span bridge. It is similar to what you have seen in FHWA design guide. There is an example of a steel curved bridge in FHWA. So I've tried to simulate that thing properly, but still some things are needed in it to get the exact results. So I will do it probably in the tutorial, and I will send you guys that tutorial. So how to start with such a thing? So I will just show you in a few minutes. So we have 3 spans of 160 feet and 200 feet the mid span, and the third span is 160 feet again. And the radius of curvature is just single radius, that is of 700 feet for the curved bridge. For the material properties, we are having the structural steel property of ASTM A709 grade 50W. It will be around 70 MPa. That's the And for concrete, we are having a compressive strength of 4 KSI. Then for slab reinforcing steel, we are having 60 KSI steel section, 60 KSI steel material properties. For the loadings on the bridge, we are having the self weight of the bridge, the live load. So for live load, we will consider around 3 12-foot traffic lanes of HL93. See, all the things are similar to what FHWA example presents. So the units, the weights and everything. The bearing surface is around 25 PSF that we have done. And then parapets and barriers is about 495 pounds per feet. Okay. So these are the section properties that we'll be considering in our model. Okay, so usually as you guys are already aware of, that if you are going to do a steel tub bridge, usually you will consider this I section separately, this I section separately, and all these things you have to consider separately. And I mean, it leads to some design issues if you model in such a way, and because it doesn't take the Saint Venant torsion properly. So if there is a torsion force, usually, if there is a torsion force if there is a torsion force, then there is an equivalent shear force that is generated inside the webs to resist that torsion. And due to these shear force, the webs might go local buckling, and so you have to consider those forces that are there. So all these things is very difficult to do it using all the design consideration is very difficult to do if you are doing it by separate I sections, right? So what in MIDAS Civil we'll do is that we'll just create a tub sections and with a slab, and we'll use the wizard to go about the modeling. Okay, and these are like the 2 sections. So for span 1 and 3, we are having this kind of a section. For span 2, I'm having the second type of section that you're seeing here. This is the construction staging information that is there. So you have like negative zones, these are the negative moment zones, and we have positive moment zones. So the positive moment zones will be first constructed in the first stage, then the negative moment zones will be done in the second stage. So these are like the construction staging information that we'll be using in our model. So we start by giving material and section properties. So we have our MIDAS Civil. So I hope that you have already attended our previous webinars and you are already aware of different menus and different options that are there. So I will not be so detailed about the options that I'm using. So I hope that you have that previous knowledge of all these things. So to provide a material information, I can go to properties, I can go to material properties, or I can right click properties and go to material. So these are like the two basic methods. So I can go to material properties, okay, and then I can click on add. So once you click on add, you have the material section property. So I can add a section of A70950W. Before that, yeah, the units are a problem, right? So if we want it in kips and inch, so what we can do is that we can go to kips from here and inch from here. Okay, so we can change the unit anytime that I wish for. So I can go to HTM9S, then provide A70950W. I'll click on apply because I need to add more section properties. So I'll click on apply. Similarly, I will add for concrete. So that will be like C4000. So HTMRC, and I can just type in here for KSI. If you wish to give a modulus elasticity, your own modulus elasticity, so what I can do is that I can just go to none again. So I can edit this menu and I can give my own value here. Okay, and then I can click OK. So these are the only two material properties that I'm using. So after that section property, if you have attended the previous webinar, likewise what I will do is that I will just switch from material to section. Okay, so I will go to section and click on add. So once you go to section properties, then there are different tabs that we'll be using. Currently we'll directly go to the composite tab. So you can add a steel box section, you can add a steel IE section, or you can add a steel tub section. So if you are having a symmetrical steel tub section, you are basically going to do using steel tub type 1. If you have like an unsymmetrical thing, then you can go for steel tub type 2. Okay, so you can have like from a reference, you can just give the positions and all the things. So I'm using steel tub type 1. So just name it as, if you remember, I gave two sections, one is section 1 and one is section 2. So I will name it as section 1. So the slab information, so if you remember from the PPT, so we have an effective width of 243 inches. Okay, and because the total slab width is around 486 inches, so each of the tub is going to take half of the slab. That's why the effective slab width is 243 inches. And based on these properties, I'm entering all the things here. So you can refer to the tutorial afterwards and check yourself. So I'm going to enter all these values: the thickness of the slab, the haunch that I am providing, so I will give 4 inch, then height of the web, B1, BF1 is the flange width. You can actually find all the information that I'm providing in here. So you can do all that information, you can find all that information in here. So I can provide if 1 is 1, 8, so 81. This is BF2 is the bottom flange 1, and it's the bottom flange thickness that is there. Okay, so we have provided information in here. Then what we can do is that because it's a composite section, so we need to convert the slab, and we need to convert the slab section property into steel section property. To do that, we need the modular ratio. So either we define it manually or everything inside, or what we can do is that we can go to select material from database and we can choose for the HTML, for the concrete we can choose the code, and for steel we can choose the property that I'm using. The moment I do that, this automatically fills up with the modular ratio information and density ratio information. Okay, so I can click on OK, and if I wish to change it, I can change it myself too. So if I want it to be 7.56, I can do it 7.56 myself too. If you're doing a manual modeling, usually manual modeling, what you do is that for a composite section, you have to lay the section first, and then probably at some stage you are having the wet concrete load over the section. We are having the wet concrete load over the section for the slab, and that wet concrete load is still it is still taken by the before composite action. That is, it's the slab doesn't have the structural stiffness yet to transfer the forces, right? So when the slab comes into picture, what happens is that the slab will act as a structural member over the girder, and then all the other loads after the composite property has been activated will be taken by the composite stiffness, right? So that's why, to simulate those things, what we usually do is that we remove the wet concrete load at a certain stage, because otherwise the slab load will be considered multiple times. So in order to avoid that thing, if you wish to avoid the wet concrete load, I just want to have the wet concrete load, and I just want to switch the stiffness properties when I wish to do it. If you want to avoid those things, then you can put ds by dc as 0. Okay, so if you put ds by dc as 0, it takes the density of slab as 0. So it doesn't take the weight of the slab when it is activating the slab as a structural member. Okay, so that is the advantage of having ds by dc. So currently we are just doing a ds by dc because the wizard will automatically do all the things, and it will deactivate the wet concrete load at a certain stage. Okay, so we'll change the offset now, as we do usually in our all the bridges. So we'll change the offset. Changing the offset means that I'm changing the load position from the centroid of the girder to the top of the girder. Okay, so I will change the offset from center to center top. Center top means that if we click on display offset, you will see a blue icon and a red icon. The red icon means that it has shifted the loading position from the centroid to the top. Okay, so all the loading will be done on the top of the girder right now, but all the forces are still going to be calculated about the centroid. So it doesn't make a difference if it doesn't change the centroid of the section basically. Okay, so if you just click on OK. Okay, and then you choose multiple modulus of velocity. Why? Because I'm not giving any age or any time dependent properties. I'm just directly giving 3n to n. N is the modular ratio, n or m, whatever you say. So n is the modular ratio that I'm giving here. So I'm giving for long term the ES by EC ratio, it increases. So instead of giving time dependent properties, so there are two methods to go with it. So one is like, if I can directly give the time dependent, I can give the long term effect of modular ratio over here, or what I can do is that I can give a proper time dependent material property. So there are two ways of doing it. So this is like the easier way. So you can multiply it by 3 and put the value here. So once you have done that, once you have given the section 1 property, I can click on apply. Then for section 2, all the slab information is same. Some few things like BF1 will change, and TF1 will change. BF3 changes to 9. TW changes to TW is remain same. B2 is 81, and this will be 1.5. And for the second section, if you go back to the presentation, if I go back to the presentation, for the second section, what we are having is that we are having a stiffener here. So if you just look at closely, we are having a longitudinal stiffener that we are having. So how to model the longitudinal stiffener? So what we'll do is that we'll go to stiffener ... that you are saying, and from here I will just choose T. Okay, I'll name this T as WT8 cross 25. Okay, and then all the height and all the information 8.13, 7.07, TW is 0.38, and TF is 0.63. Okay, and then we click on add. So once we have done that, then we have to choose which position do we want to have that stiffener. So it's an end bottom. So I'm going to have one at the center of this of the bottom flange. So what I will do is that I just fix it. So I will just give it as 41.5. Okay. So if you wish to actually count the stiffener count the longitudinal stiffener area into the stiffness calculation of the full stub girder, then in case you check on. If you check on, it will consider the stiffness of this longitudinal stiffener also in the tub girder section properties calculation. Okay. So we'll click on OK. So we have this small longitudinal stiffener that we're having here. Rest of the things are same. So we'll click on apply for section 2. Now between the tub girders, usually you can either have bracings or you can have end diaphragms. So depending upon your project, if you wish to have an end diaphragm or if you wish to have an bracing. So for current application, I'm just providing end diaphragms. So I can give like solid rectangle and name it as diaphragm. So we don't have a database for solid rectangle, of course. So what we can do is that we can go to user and we can type in 78 for height. It's approximately equal to the depth of the tub girder. So it will cover full tub girder. That's what we meant to do. Okay, and we'll just go to center top and we'll click on OK. Okay, so once you are done with this, then you can click on apply for diaphragm. And one more section that we need is WT9. Okay, so we need this section too. So we can go to the database and then we can go to T section from here. Okay, and then we can choose that particular section. This is for the cross bracing basically. So I will explain why do we need this and how do we do it. So it's here. Okay, so this we can change the offset to center. We want it in the center offset, the loading line to be aligned with the center. Okay, so once we are done with it, we can click on OK and we can close it. So all the section properties and all the material properties I've given. So if you go to workstree, you have all these properties already given, and the creep factors that was there, section stiffness factor that was there, has already been incorporated. But the thing is that it hasn't been defined anywhere. It hasn't been assigned to anything. That's why it is showing in blue. Okay, so the next step will be to manipulate the wizard. So we'll go to structure and then we'll go to steel composite bridge. This is the wizard for steel composite sections. So instead of girder type composite tie, I'm going to choose as a composite steel tub. Okay, so you have the capability of doing all frame, or you have the capability of doing deck, the deck element as plate element and the girder, that is the tub, as frame element. So you have both the capabilities in MIDAS civil. So for our purpose, I'm choosing for all frame. I can give the span information. Remember, the unit is in inch. Okay, so if you wish to change the unit before, just go here and change your unit to feet and you can change it. Okay, so I will give all the information in inches. So I have 3 spans, so I'm giving the span information using a comma in between. So it's like 1920, 192520, and then it's 1920 again, same. Okay, And deck width, if you remember, 243 into 3, it is 486 inches for the deck width. Okay. So if you have like a multiple curve thing, if you have multiple curve and with different skew angle at each position and with different banking, with different elevations and everything, then you go for multi-curve. So in that case, this is the information that you need for multi-curve. Okay, so it's like this is for transition curve. So if you have a curve like this, something like this, okay, so you define the transition curve, then you define the radius at the mid for another curve, then you define another transition curve. So all these information you have to enter in here. You have to enter the vertical curve information. That this is for like elevation. So if you have bridge at different elevations like this, then you can provide in that way. And this is like bank rotation. So if you have like the surface at a particular bank, then you can provide it in here. Okay, so it will be in this manner. So all this information you can provide it here. For our case, we're having a simple curve bridge. So even you can simulate the same thing with your multi-curve, but simply if you have to use, you can use radius. Okay, so we'll just enter the radius, okay, and then we'll enter the bearing type. So either with substructure or bearing type. For our case, I'm using bearing type. I'm using the supports. Okay, so fixed support I'm giving as pier 1. So for our case, it will be like similar to this case, as you can see here. Okay, so I have like 2 bearings here, 2 bearings here, and 2 bearings here, 2 bearings here, and 2 bearings here. So I'm giving like pier 1 as fixed, in between as fixed bearing, and all the other bearings will be automatically decided by the software. Okay, and I hope that you are already aware of the center of the reference line and center of the deck. So here you have something called layout offset. What this means is that currently the centroidal line is the line to the centroid of the deck. Okay, and if you want to change the reference position from the centroid of the deck to any reference line, you give an offset. So basically, if you give a reference line at an offset, then you define all the girder positions from this reference line. But currently, if you have given 0, then what will happen is that all these webinars, all the girder informations will be provided from the centroid of the deck. Okay. So once you have done that, don't forget to save the wizard. So we can save the wizard as some file. Okay. Similarly, we can go and add section information. So we have a deck thickness of 9.6. I can give the number of girders and everything. Since I have already saved the wizard, okay, so what we can do is that I can just double click on the saved thing, and I have all the inputs of the wizard that I already inputted, right? So currently we are not having diaphragms at each end, so I'm just going divisions per span as 1. So it's like only at the span end I'm going to have a diaphragm. Okay, and then is section 1 is okay. So for deck we are giving the material information as of concrete. For the girder we are giving as steel. For the bracings we have to, since our bracing is a diaphragm, so I'm giving as concrete. And then we have the girder offset. So I have currently 2 girders, right? If you go back to the presentation, so I have currently 2 girders. So both of them are like you have a total thickness of total deck width of 486 mm, and each of them is sharing 243 mm. Okay, so the angle type I have given as perpendicular, so the diaphragms are aligned with the curve. However the curve is going, it is aligned normal to the curve, And since we have different sections for different spans, so I have given the section property in such a way. So for 0 to 1920, this is for the first span, I'm having section 1. For 1920 to 4440 inches, I'm having section 2, and for the rest, I'm having section 1. So it's been aligned in such a way. So for Girder 1, and this is for Girder 1, and for Girder 2, if you want to copy the Girder information, I can simply go and click on this and click on OK. So it will copy the same information on the Girder 2 also. Okay, and there is something called generate 10-point elements. What it does is that it automatically gives you the results in 1/10 of a span. So you don't have to create nodes in between, it will automatically do it. Plus, also one thing we have is that we have a transverse deck element. Basically, we are not actually having a slab, right? We are only providing, what we have provided till now is just a composite section property of a single line. Okay, so it's like a single line. Okay, so in order to simulate the slab, what we do is that we provide cross beams in between, having the same stiffness as that of slab. So it will have the transverse stiffness of the slab. So the spacing of the cross beams you are deciding from here. This is the spacing of the cross beams. So basically, based on the spacing and based on the things, it will automatically calculate the cross beam section property and add it. Okay, so you'll see it once we do it. Then if we go to load information, then we can give the B1 dimensions, the other dimensions. I'm not having a median here, so I'm just giving 0. Then the formwork, if you have wet concrete load, so all these informations, the varying surface load, the barrier weight, so everything has been calculated as per the values that I have given you before. In order to give moving loads, I have to first decide the moving load. So I will just click on define moving load. I will click on Astral RFD, click on OK. Then I go to traffic lanes. If you remember, I have 3 traffic lanes, right? So currently, it's like from the end, it's like we have given as 12 feet, right? 12 feet lanes. We have 12 feet lanes. So, but what the lane width that I have taken is around 8 feet. The reason for this 8 feet is because in MIDAS you have something called traffic lane optimization. In traffic lane optimization, what it will do is that it will place the vehicle at the left end of the lane, at the mid of the lane, and at the right end of the lane. Okay, since in the code it is mentioned that you cannot have a vehicle within 2 feet of the lane ends, so that's why what I have done is that I have removed 2 feet on both ends and I've given 8 feet. So I have given the information in such a way that the vehicles can be placed at the edge of the lanes. Okay, so we are having 3 lanes, so I've given 3 lane informations. For defining vehicles, I can go to define vehicles and then click on add standard, and I can give a 33% of dynamic allowance. And for a tandem, we'll again choose 33%. So this completes the live load and the dead load information that we need. Next we come to construction stage. So if you remember, for the construction stage analysis, I showed you a layout, right? So we go to the layout again. So we have a layout in such a way. So we have to define these negative moment zones, right? So in order for the software to decide a proper construction stage, we have to define all these things. So to do that, what we can do is that we can go to advanced in here. So I have provided for the pier 1 to the left how much of the length I should consider, to the right how much of the length I should consider, and for the pier 2 how it should be. So you can provide information in here. Similarly for deck split construction, so I am considering for the first stage that D1, D3 and D5 be constructed, and for the second stage I'm providing the information that D2 and D4 should be constructed. So you are providing exactly how you are going to have the forces. Okay, so once you have done that, then you go to long-term boundary and then you check on both the things like creep 1 and creep 2, because we are considering the long-term boundaries. Reinforcements, either you can define it now. So if you go to reinforcement, define reinforcement, it will open the section property calculator for the section. So you have basically a lot of ways of providing reinforcement, but the one that I like a lot is that you can go to line, you can go to input method B, you can just choose the first point and the last point, and you can give a number like I'm providing 20 reinforcement of this much dia, so I can just provide like this and click on add. So the moment you click on add, it will add on reinforcement. Okay, so in the same way you can add for the other section too. So once you are done with this, you just click on OK. And you have the full model ready in front of you. Okay, so this is like for the end diaphragms. So many people they tend to give a diaphragm covering the full top section. You can do that way also. You can consider this way also. It's up to you how you want to do the analysis for the bridge. Okay, so some people prefer just giving an end diaphragm like this. So you can provide an end diaphragm like this. And currently, if you see that I am having two steel tub girders, but there is no bracing information inside the tub girder. So unfortunately, currently we are not providing that bit of flexibility that you can provide the bracings in here. But there are a lot of ways that you can use to provide bracings. Okay, so if you have like an AutoCAD file already for the bracing information, so what you can do is that you can just go to MIDAS Civil, you can import, you can import doing an AutoCAD DXF, then go to browse, and like I have these informations already, so I can choose the bracing information. I can choose a section that is not there already, so it's like I have like 8 sections, so I will give 9 here. Okay, and once you have done with that, like section, you can give the scale factor, and once you have done with that, you can just click on OK. So it will just import all the bracing information. So this is one way of doing things. Another way is that if you work as a team, right? So what you can do is that if you're working as a team, so one person can create a bracing information, one person can create this full model and work on it. So if you have a model already that has the bracing information, so what you can do is that you can go to MIDAS Civil, you can go to merge data file, and then you can go to the model and that you have the bracings for, and you can make a group out of it. Okay, and then you can choose intersect frame elements, so that wherever the nodes are there intersecting the line element, it will intersect the frame elements, and then click on OK. So this is one more way of merging two files. Okay, so either you provide a bracing in that way or you provide a bracing in this way. One more complicated thing is to have like even if you have like bracing information and all the other things, you need to provide links in between. Okay, so currently I have the bracing information. Okay, currently I have the bracing information, but I don't have the links in between, right? So to provide links is like is a little manual task. So usually what you can do is that you can go to boundary, you can go to rigid link. Okay, so once you have done that, you can choose the master node, and you can choose all the nodes of the bracings that are there. So before that, what I can do is that I can select only bracing group that I did and activate only this group. So this will just ease my view a little, and then I can select all the nodes. Okay, so I can go about doing it one by one. So this is like a little manual task that you have to do. So if you display it, it will look like something like this. Okay, but the thing is that there are a lot of ways. I mean, this is not the only way of doing it. The other way that I was telling you is that what you can do is that you can just select these elements, like the end elements. I'm just selecting all these end elements, right? So if you are very conversant with MIDAS, you will feel that there are a lot of ways of modifying things. So what I need is that I need a very good pattern of node numbering. So what I can do, I can go to node or element, I can go to renumber nodes. Okay, so in here for the selected nodes, I want to renumber from, say, 3000. Why 3000? Why not 1? Because 1 to 2777 nodes are already there inside the model. That's why I'm saying 3000. Okay, so once I have given 3000, I can give as plus x, plus y, and plus z as the information, and then I can click on apply. So once I do that, if I go and show you the bracing information here, and I show the node number here, so you'll find that everything is ordered in a particular way. Okay, so then you can simply use the node numbers in Excel to add the bracing information. So I can have, like, I can go to rigid link from the works tree, go to tables, and I can add like 3183 is 3183, and I can add this bracing information in a particular pattern. So you can follow that pattern in Excel, you can copy that thing in Excel and you can paste it back in here. So this is like, these are like few tweaks you can do. I will be mentioning all these things inside the tutorial, so it will be very easy for you to follow all these things that I am providing. So this is for the bracing. I have a model which is having all the bracing information. I'm going to show you in a while. So before doing all these things, one more thing that we have to do is that currently all the bracing information, I will uncheck the nodes. I have to provide them the section property of WT94848.5. You remember, right? So I have not used that property anywhere. So what I can do, I can just simply drag and drop over it. Okay, so this is something that you can do. Similarly, I can drag and drop the material property. I can remove the excess material property that is there. I don't need it. Okay, so once I've done both these things and provided everything, still our structure won't work. Why is it so? Because we have provided some construction staging information, and I need to add those elements that I have given right now inside the structure group, right? So what we have to do, we have to select all the bracings, group, and if you go to the first stage, like if you go to the first stage from here, go to stage 1, you will see the substructure, girder and bracing groups are activated. So what I can do, I can just right click on bracing and click on assign plus. Similarly, if you go to the groups again, if you go to the first stage, if you go to the boundary group, you have substructure deformed group that has been activated. So I have activated the bracings, but I have not done anything for the rigid links, right? So I need to activate the rigid link between the bracing and the top of the deck. To do that, I can just again double click on only bracings group, and I can drag and drop, or I can just right click substructure group, click on assign plus and click on OK. So what it will do, it will automatically, when I'm doing this assign plus, I'm choosing all the boundary conditions with it. So since there is rigid body link that has already inside this selection box, so all the rigid links will be selected inside the group. Now your model is complete. Now it will run without any error. Okay. Before we proceed, what else that we need to do is that currently we are having only lanes for the moving load analysis. Currently we are having only lanes, like 3 traffic lanes. So if you just right click on traffic lanes and click on display, so we'll have like 3 traffic lanes over the bridge. Okay. So if you remember, I was telling you that you have to so what you have to do is that you have to consider traffic lane optimization, right? So in order to do that, what you can do is that you can go to properties of each lane and you can check on traffic lane optimization. Okay. And you can get the lane width, total lane width that is there for the traffic lane optimization. Okay. Similarly, you can go to lane 2 and do the same thing. you can check on traffic lane optimization, and similarly you can do the same thing for the lane 3. So I can just undisplay the things, and I have got the vehicles, I have got the traffic lanes, but the thing is that again you are seeing that these are in blue, so that means that these have been defined but it hasn't been assigned in the model yet. To assign it, I need to add moving load cases. So what I will do is that I will go to load, moving load, and then I will go to moving load cases. So once I have done that, I'll go click on add. Okay, so I will add like one moving load MVL. And this will automatically take care for the multiple presence factor that is there in over the bridge. Okay, and then you can choose either combined or independent. Okay, so I want HL93 and HL tandem to work independently with each other. So what I can do, I can click on add. So I can choose all 3 lanes on selected lanes. I can give the minimum number of load lanes as 1, maximum as 3. So what it means is that currently HL93 tandem vehicle with a scale factor of 1 will be running over each lane. So it will be running like if these are the lanes, so it will be running over each lane one by one. Then a set of 2 will be running in each lane, so there will be multiple combinations that you were thinking, right? So there will be a lot of combinations that it will provide automatically based on the information that you are giving here. So once you click on OK, you can give like for truck similar thing 1, 3. Okay, so if you click on independent, these combinations will be running independently, and the case will be showing you the maximum result irrespective of the combination that you're giving. Okay, so if you wish to see the results separately for each combinations, then what you can do is that you can give a separate load case for them. So instead of providing both the information here, you can provide a separate load case. If you choose combined, then it will do internal combinations among the combinations that has already been done. So that's like a very complicated thing. So if you wish to do such cases, then you can do in that way. So that makes the moving load complete. So once you have done with that, then you can go to once you are done with the moving load cases, then you can go to analysis. You can go to moving load analysis. Then I can provide the influence line dependent point or all points. So if you click on all points, this influence generating points won't make any sense. So you can just click on influence line dependent points, and number per line element, this is the increment that I'm giving. So I can either give 2, I can either give 3. So for each line element, it will place the vehicle over here, and over here like this. So it will divide it into 3 parts. It will divide into 3 parts, and it will provide the loading over here, and at the ends. Okay. Similarly, you can choose normal plus concurrent forces for the to calculate the concurrent forces also for the moving load, and then you can choose all the reactions, displacement, force moments. Okay. Now the thing is that a lot of questions that I get is the moving load is really slow. But the thing is that you have to understand that this is kind of a huge bridge, right? And you are doing a traffic lane optimization, and it is doing so many combinations. It's not like it is just doing the combinations that you are providing. It is doing internal combinations. It is providing, and it is doing it for 3 positions for each lane. So depending on the number of lanes, depending on the length of the bridge, it will take time. If you wish to perform it much faster, then you can create a structure group. Like I want the solution to be, I want the solution only to this portion of the girder. I don't want solution to other portion of the girder, because that I'm designing only that much portion of girder. If I want a solution only for that much portion of girder, I can specify a group in here for moving load, and then I can just click on group, and I can choose the group that I want to get the analysis for. Okay, in that way you can filter out the results very quickly, and you can get your moving load results very quickly. Okay, so this is what we can do with the moving load. I have already performed the analysis for this kind of a bridge, so I will directly open up the analysis result. So this is the model which is already having the analysis done. So you can see here that I told you, remember that P of 1 is fixed. So P of 1 is fixed. So according to that, all the other elements are having really all the other boundaries are having releases as per what we have given. And automatically what the wizard as it does, it gives the nodal local access. So you don't have to worry about local access of the nodes. So it automatically provides those nodal local access. So once we have done that, if you wish to check the results for only Girder, so what I can do is that I can go to group, I can just double click on Girder, I can activate that. So I will just deactivate all the bracings from here. Okay, so once we have only the girders, I can go to force, I can go to beam diagrams. So I can choose for MV max moment. So this is the maximum possible moment that is there in any of the locations that are any vehicle location. Okay, and for if we go to MV min, this is the most negative moment that you can get throughout the bridge in all the locations. Okay, so you can check on legend and click on apply to find out which is having the minimum most negative moments. So this is like 762. So I can type in 762 here, press enter, and activate that. So it will just activate the element there. Okay. So once you have done that, then you can go to either solid fill and check the results like that. Or if you wish to see the results in between this element, you can just go to quick view and go to element, click on this, and then you can choose any position and you can see the value for that position inside that element. Okay, so once we are done that, so you can go to, if you wish to if you wish to see the construction stages, you can just go to construction stage information. So in the first stage, if I go to initial view, in the first stage only the bracings and diaphragms are available. In the second stage, in the third stage the deck is there and the wet concrete is deactivated. Third stage, in the fourth stage I have the full deck there. So this is like the construction staging that the software has performed internally. For other results, like if you wish to see the other results like deformation and reactions, you can go to reaction and go to reaction force and moments. Okay, and click on FZ and click on apply the reaction forces. Okay, I hope that you are already aware of these things, so I'm not going to spend much time in showing you the results. So for design, usually what you do is that you go to results, then you go to load combinations, and then you go to composite steel girder design. So if you click on composite steel girder design, you can just remove this probably, and then click on auto generation. Okay, and if you wish to change other parameters, so you can change the other parameters in here. So I can give like you go here, you can find out the different indexes for different bridge components and how the factors are going to be taken. So you can choose B, C, D like that. Okay, and once you have done that, you can just click on OK. Just a minute. Sorry, I'm in the construction stage, that's why it is not working. So you have to go to post CS, so load combination, then you go to auto generation, same thing, and then you click on OK, and once it does, you will see all the load combinations that are there for that particular information that you have given. Okay, so once you have done given the load combinations, then you go for design. So once you've generated the load combinations. Also, if you wish to design the bracing, then you go to steel design, and again you do the same thing. So I already have the information for steel design, so you click on, you just click on auto generation, and you click on OK, and you get the information for, or you'll get the combinations for steel design. Okay. Then I go to design. So before designing like the composite design, you can provide span information for the girders that you are providing. So you can just activate the girders. I will deactivate the, just a minute. So you can activate the girders, and you can choose spans in between. So like if I display, so I can choose like this span, complete this span, and I can go to structure, go to the pre-processing mode to do that. Okay. So I can choose a particular span. So I can choose this particular span and go to structure, composite bridge, span information. So I can provide span information in such a way. So like if you click on add or replace, you will get all the information. Then you can provide where is the support. So at the ith end, I'm having the support here. Okay, and at the jth end, we're having the support at this end. So this is the span information. So you can enter the span information. The use of the span information is that when it gets the design results, it will give you the design results for each and every span, each and every element inside the span information. So once you have done that, then you can go to PSC, or you can go to design, and you can choose the code, and you can choose the design parameters. Since it's multiple box section girder or multiple tub girder, so you can provide multiple box and tub. So automatically it will consider the Saint Venant torsion and distortion stresses. Okay, and you check on all the strength limit states and the design parameters that are there. Okay, so we can click on OK. So then you can go to design material. Okay, so we can have the design material that we are having. So we can have the, if you wish to have different flange, different top flange and bottom flange thickness and other things, you want to consider different grades for them. So you can provide a hybrid factor. Okay, or else you can give the grade from here. You can provide the concrete grades and specify the grade of rebars that are there. Okay, so once you have done that, once you have done with that, then you can go to load combination type. Automatically the software will provide it inside the strength limit state, different strength limit states that are there. Then you can go for longitudinal reinforcement. See, there are a lot of ways of, lot of places where you will find it. So we have already entered the reinforcements, so we don't need to enter it again. And similarly, we can go for transverse stiffness. So if you wish to give a transverse stiffener, you can provide a transverse stiffener in here inside the tub section. If you wish to give an unbraced length, so you can provide for the entire bridge or a few sections the unbraced length, and you can provide a laterally unbraced length as some value. So currently it's like 200 inch, so I can provide like that. Okay, so I will just uncheck the bracings. Somehow I have just given the bracing information with it, so I will just uncheck the bracings that are there. Yeah, this looks clear. Once we have done that, then you can go to design position. So you can provide a design positions. So currently what the design positions that I'm providing is the maximum and minimum moments where I was getting. So if you remember, if I go to results, right, if I go to forces, beam diagrams, for the maximum moment that I was getting, I'm just choosing it for the moving load. So you can do it for the load combination that you would actually you think is the governing. So this is like 417, I'm getting the maximum, and for moving load minimum it's 762. So I'm choosing both these design positions as the design position. So I can choose like INJ and put in 716, 762 and 417 like that, and then click on apply. So once you have done that, you can provide an output position. Output position is something you should provide only for few elements, because otherwise the software takes quite a bit of time in generating the output for all the elements. So you should provide only a few elements for output positions. So then you have share connector, so you can provide the share connector informations inside this menu. Once you have done that, then you go to fatigue parameters, so you can provide different fatigue parameters too. So you can provide the codes, and it will automatically calculate the different things that are there. So you can choose all the elements, and you can provide the fatigue parameters too. Okay. So once you have done that, then you go to deck overhang loads. So if you wish to provide a deck overhang load, you can provide in here. So once you have done that, you just click on design. And says that the steel girder has designed. So it is actually quick because I have selected only a few points. So I can go for either span checking or total checking. If you go to span checking, it will show you all the things. So currently somewhere it's failing some elements in this inside the span, so it is showing those things where it is failing. So you will find NG and NG where it is not good section. Wherever it is okay, you will find okay. Similarly, if you go to composite design and you go for total checking, okay, so you'll find informations regarding total checking. Okay, and other things, like if you wish to see in detail, like only for strength limit state, so you'll find that the strength limit state is fine for the sections that I've designed. These are basically the sections that I've designed. I'm checking the design for. Similarly, if you go to share, it is failing. So if it is failing, that means that we need a bit of share connectors and other reinforcements, right? And then we have like service limit state. So you can go and check about all these sections, all these options one by one. You can also go to design result diagram and go to node. So for span 1, the span 1 information that amount of moment that is coming at that node, and the green is the design moment. Since it is doing only for a section at INJN, so it is showing like that. Similarly for span 2 you will get, okay, so for flexor it is easily passing, you can see it directly from here. So once you have performed all these checks, then you can go for Excel report. Okay, so if you click on Excel report, then it will generate an Excel report, a detailed Excel report of the things. So I have already given the Excel report. So this is what it looks like. So for a 762 element, these are the reinforcement information with the tub information that is there. It will show the girder section property, the transverse property, the elastic section, the short term, long term things. And then we have design strength, transverse stiffener properties, flexure properties. Okay. So it checks each and everything inside the code and provides you the information. Here it is checking for Saint-Venant. So this is like Saint-Venant shear force that it is checking. Okay. So for each and every thing that it checks, since we provided shear connectors for a few elements, it is showing that few things are not good. So we have to provide the information according to that. So you can check this and you can remodel your say connectors and other things that are there. So this is something that actually needs time, and I mean design, it will take a few iterations from your side, but you ultimately will find a complete report that is generated from the software. So if you print it, it will generate it in a, it will show in a very printable format. Okay, so this is for the design of steel tub sections. So once you have done with the steel tub sections, if you wish to do it for the bracings, so what I will do is that I will just activate the bracings. So currently if I wish to do only for these bracings, so instead of going to composite design, what you can do is that you can go to steel design, you can choose the design code, you can check on all book if you wish to do it, and then you can provide the strength reduction factors, modify steel material, and once you have done that, you can either go to steel design result or steel code check. So if you go on steel code check, it will check the steel, the bracing that is there. So if you go to graphic, you have to select a member, so I'm selecting this. So it will give you a graphical information of the parameter checks it has done. This is like summary of the bracings and for the lengths and other things. Or if you click on detail, it will give you a complete detailed report of the forces it has considered and all the things. It's kind of like a design report for the bracings. So this is in brief about what the things are there. So as I told you that I am currently doing the FSW example, so in the tutorial I will try and replicate the things that have already been done in the code, so you can easily check the things and other check the things yourself. So I will be taking a Q&A session right now. So this is how very simply you can actually do the composite section. Yeah, for a few more questions usually that we get, like how do you check for corrosions and things, right? So if you wish to do corrosions, like if I say that a particular portion of my section, like these portions are corroded, if you want to check the manipulate the corrosion for a particular section property, so what you can do is that you can go to properties, you can go to section properties, section manager, and go to stiffness. Okay, so inside each and every section you will get the sections that are there. So it's for steel. If it's for the steel stub section, what you can do is that you can go to a particular element, and then you can give your reinforcement scale factors in here according to what you want for the corroded section. Okay, so this is something you have to go to default, of course, and this is something that you include in the corrosion. Like you have to decrease the stiffness of the section where there is a corroded section, right? If you wish to model the corrosion, then you have to go for plate elements and do the model. Okay, these are the queries.
Okay, these are.
Okay, so this is how you will do corrosion inside, and it's the top lateral bracing we will do it in the same manner. There's no other difference inside MIDAS Civil. One thing you should understand about the software is that anything that is horizontal, the software will directly consider it as a beam. Anything that is vertical, it considers it as column. and anything that is slant, it considers as bracing. Okay, so by default, if you design it, you can design it automatically by the software will automatically take the things into consideration and it will do automatically, right? But if you wish to design a column, suppose in term as a beam, then you have to modify the material type. You have to modify the section type as column. That's the only section type is beam. That's the only thing that you have to do. Yeah, for span information, yeah, it is needed for. It is mostly needed for design. It gives a very good representation of the entire elements in summary. It gives a good summary of all the things, so you don't have to go to element by element and check the results. It gives a complete for each span information for the elements that you have given. It gives a complete summary of results in there. Okay, so that's a use of span information. Otherwise, even if you don't give span information, it will do the design. It's not necessary to give span information. Yeah, that's a very valid question. That if you have like construction stage and static load cases, then it will add it to twice, right? So usually what you do is that all the static load cases that you're giving, like if you are providing the wind load as a static load case, so what you do is that, and self-weight as a suppose construction stage in the construction stages. So for the load cases, if I go to load cases, if you see here, the wizard has automatically provided everything in the construction stage type, right? So whenever a load case type is defined as construction stage load, what it means is that it will only take the information of that load case in the construction stage. It won't consider that in a static load as a static load case. So you don't have to worry about that. But had the self-weight be given a load case like dead load, right? If you have given like, I mean, it will delete the analysis, but if had you given it like dead load and then included the self-weight in the construction stage, it would have considered it twice. So you have to be very aware of the things, aware of the load case that you are giving. So whatever load case that you are giving in the construction stage, give the type as construction stage load case. Okay, so that's the thing. Okay, guys. If there is any more questions, I would love to answer it over our email ID. So if I will share you the. So for technical support, you can just send us at ts@midasit.com. I hope that the session was useful for all you guys to get started with the tub girder bridge. You will be getting the tutorial in a while. I'm sorry that I'm still working over it. So I will just go over each of the things in detail, and I'm sure that it will be really helpful to all you guys. And thanks for your presence, and hope you have a nice day.